This is 8.5. We're going to be factoring what we call simple quadratics of the form x squared plus bx plus c. And I'm going to go back a little bit to what we talked about a few sections ago, and the idea of GCF factoring. So we always want to try and plot a greatest common factor first before we use the techniques that we're going to learn on today's. So just a quick review here. Looking at this first one, the GCF is 2, and then what's left over we get through division of each of these terms by the GCF. 2x divided by 2 is 1x, and 16 divided by 2 is 8, and you can check through multiplication. 2 times x is 2x, and 2 times 8 is 16. That'll at least check that you've factored it. It won't necessarily check for the greatest common factor. The greatest common factor, you need to find the biggest term that will divide into each of these terms. And so we're looking at the number that will divide into each of those with no remainder. And in terms of variable expressions, we're looking for the letter to the lowest power on there. And so, for example, in the second one, the number for the GCF would be 6, and the letter would be y to the first, because of the first power on the y on the second term. So then when I go to divide, you'll see that 18 divided by 6 is 3. Using what we learned when you divide two variables that are the same base, you subtract the powers. Remember, there's a 1 power on that, so it gives us y squared. Dividing that term by 6y to the first will give us 2. And so copy down the negative sign. This last one on here, we have 3 terms. Looking at this, you can, I think, easily tell that the greatest common factor is going to be 4 in terms of numerical values. And then you look at these, there's an m, and an m, and the lowest power on the m is m to the first. And then I do not see an n in each one. There's an n in the first here and an n in the third, but not in the middle one. So 4m is my greatest common factor. I'm going to divide each of these by 4m. So I'm left with 16mn divided by 4m is 4n, and 20m squared divided by 4m is 5m, and negative 8mn squared divided by 4m is minus 2n squared. So that is greatest common factor factoring. And so that's the first thing you want to do on each of these. Now, something like this is starting to look like the form of what we're going to be learning to factor today. But what could happen is that you pull out a greatest common factor, and what's left over can be factored using the methods of today. So we're going to look primarily at what are called quadratic trinomials here. So I'm going to give you many different ways to factor a quadratic trinomial. This is one of them. It's sometimes just informally called the big X method. But trinomial factoring is dealing with 3 terms here. You can see the 3 terms, 1, 2, 3. And it's a quadratic because of the second degree here. And this is a process for being able to do that. We are looking for specific values. There is a unique factorization of x squared plus 7x plus 10. In other words, there's one way to rewrite this sum of terms as a product of 2 binomials. And we're going to find out what those 2 binomials are right now. So it says multiply the front and back numbers to get the top. So there is an unwritten front number here. We call it 1. There's an unwritten 1 in front of that x squared. The back number would be the 10. So when we say multiply the front and back numbers, it's the 1 and the 10. So 1 times 10 gives us 10, and we write that number right there in that big X. This is just a way to organize your work for thinking about factoring. It says the middle number goes on the bottom. The middle number is this 7 right here. You've probably solved little problems like this in courses leading up to this, probably in middle school. They start working on these. It says now find 2 numbers that multiply to the top number and add up to the bottom number. So what you're considering is all the different factors of 10, and we want to list all those out. I know some of you may have in your brain already what two numbers multiplied equal 10 and added equals 7, but I want to write all the factors of 10 down in a systematic way so that we're sure we've checked all of them. Sometimes it won't come to your mind right away, and we have to make sure that we've thought of all the possibilities before we decide if it can even be factored. If nothing will work, it can't be factored, we would call it a prime quadratic trinomial. So 1 times 10 equal 10, or 2 times 5 equal 10. Those are the only possible factors of the number 10. Now 1 times 10, although they multiplied to equal 10, add up to equal 11. So that's not going to work for this big X. But the 2 times 5 do add up to equal 7. And so it's the 2 and the 5 that multiply to equal the top number and add up to equal the bottom number. And it says these two numbers are your factors. In this case, we are done. We've found the 2 and the 5, or pretty much. And what we're going to do is use those to rewrite this quadratic trinomial up here. So in other words, x squared plus 7x plus 10 as a sum is equal to a product of two binomials. You may have recalled this from our lesson 8.3 and also 8.4. We were actually multiplying two binomials, and our answers would look like this: x squared plus 7x plus 10. So we're working in reverse of that, opposite direction. So we have x plus 2 and x plus 5. That's how you write it, using the 2 and the 5. You pair it with an x. And those are the factors. So this would be equivalent to saying, hey, we got 12 is equal to 3 times 4, or 10 is equal to 2 times 5. We're doing this part. We're finding the factors of the quadratic trinomial. So what you should notice here is that if you factored correctly, you could take the x plus 2 times x plus 5, and using the distributive property, or using your table, whatever method you want to use, using FOIL, you could get back to what we started. So x times x gives me this x squared. X times 5 would give me a 5x. 2 times x would be a 2x. If you add those two, you get the 7x, which is the middle term. And then the 2 times 5, when we distribute that, gives me the 10. And so I can check through multiplication that I've done my factoring correctly. So that's how the two are related. So that's factoring. One method is using what's called the big X. So factoring if all is positive, that's the example we just did. It's pretty simple. If all are positive, we use the big X, looking for factors of 15. Remember, it's the first term, that unwritten 1, times the last term 15 to get the top number, and then the 8 is my bottom number. Now, I know some of you already have it, you've already figured it out, but we're going to list all the factors of 15. It's either 1 and 15 or 3 and 5, and only one of those sets of factors in the list actually add up to equal 8, and that would be the 3 and the 5. And so I'm saying this is equivalent to the following set of factors, or product of factors: x plus 3. Oops, and I miswrote that. It should be a 5 over on one of these should be a 5. It's got to be these two values here and here. So 3 and 5. So x plus 3 and x plus 5 is the factored form of that quadratic trinomial. So if you could try the next two, you can pause the video. I'm going to just go ahead and give you the solution. On the second one, I'm not going to just give you the solution because there's something new. We're combining a couple of ideas. It says GCF first. This goes back to the beginning of the lesson. We are going to pull out the greatest common factor first. And my greatest common factor for these three terms is going to be 3 for the number. 3 will go into each of these. Nothing any bigger will go into 3 without a remainder. And then x to the first power. Notice there's a first power on that x. So that's the minimum power of all the x's that are common to each of those terms. So 3x is my GCF. going to pull that out. I'm going to divide each of these by 3x to get the leftover terms. So we're doing the GCF first. So we've got x squared plus 5x plus 4. And what's different about this one from the beginning problems is that I can take this a step further. Looking at just this guy right here, it can be factored further. So I'm going to bring down the 3x. That's one of the factors. It would be like taking, the number, say, a number that would work for this. Well, even my 12 would work. But the number 12, I guess we could take that. And if it's not the GCF, but if I just took out a 2 here, then I could factor what's left over, the 6, into a 2 times 3. So that's kind of the idea of what we're doing here. Is we've taken out a common factor, but then what's left over can be factored further. It's a little different in that we've pulled out a greatest common factor. So, so what we're going to do is we can do our big X on this second part. We're looking for factors of 4 because we have an unwritten 1 in front of that x squared that add to equal 5. And so my factors of 4 are either 1 times 4 or 2 times 2. So my only options, the 2 and the 2 work. Oh, my goodness, we got to add to equal 5 though here. Sorry, so the 2 and the 2 do not work. The 1 and the 4 work because they have to add to equal 5. So once again, my only options for factors of 4 are 4 times 1 or 1 times 4 and 2 times 2. And the 1 and the 4 add up to equal 5. So we're going to use those and write this out as x plus 1, x plus 4. So just to show you kind of what we're doing in reverse. This is the factored form, completely factored form of the above trinomial. Just to show you that we've done this correctly, look what happens here. If I take just this part and multiply it back out, the x times the x would give me x squared. Remember, I have the 3x still out here. We'll put block parentheses around this. But I have x squared, and then x times 4 is 4x. 1 times x is 1x. 1 times 4 is 4. If I combine those two middle terms, I have x squared plus 5x plus 4. And that's getting me back to this stage here. And then if I distribute the 3x, as we did in the first section of this chapter, 3x to the third plus 15x to the second plus 12x gets me back to where I started, the original problem. So what I've boxed here is my factored form of this original problem, and I just did a check here to show that it does in fact equal through multiplication. All right, factoring if b is negative. So we're still going to, at this point, use the big X. We are this time, though, looking for factors of, remember there's an unwritten 1 there. 1 times 24, which is positive 24, that add to equal negative 11 this time. So if b is negative, we have a negative term there in the middle. And so when I list my factors, I need to consider factors of 24 that are both negative because they have to multiply to equal a positive. Remember, a negative times a negative would be a positive, so negative 1 times a negative 1 would be a positive 1. So they've got to both be negative factors so that when I multiply them, I get a positive, and when I add them, I get a negative. So my possibilities for 24 would be negative 1 and negative 24. That's one possibility. Another one would be negative 2 and negative 12. So what I'm doing is I'm starting at 1 and 24. Then I move up to 2. Does 2 go into 24? Yes, it goes in 12 times. Both are negative because they have to both be negative when b is negative and the last term is positive. Go up to 3. Does 3 go into 24? The answer is yes, it does. It goes in 8 times. So there's another possibility. Now some of you may be thinking, well, that's the one that works. Negative 3 plus negative 8 is negative 11. But we're going to list all the possibilities just because we want to get in the habit of doing that. What you'll find is that not every quadratic trinomial can be factored. There could be a prime one, and you won't know it's prime unless you've looked at all the possibilities and none of these possibilities here add up to this number right here. If that's the case, then it's what we call prime. But in this case, you can see that -3 and -8 do in fact multiply to equal 24 and add to equal -11. And so my factorization of this guy, I can sneak it in here, would be x minus 3, x minus 8. And so this is my final answer. That's factoring x squared minus 11x plus 24. So I'm just rewriting that. Okay, go ahead and try now you try here. You can go ahead and pause the video. I'm going to put up the solution. When you unpause it, it'll be there. Alright, so hopefully you got those factors using your big X. On this next one, I'm going to go ahead and go through it again. We're going to factor out a GCF, which in this case would be 2y, and through division, get our other three terms. So 2y cubed divided by 2y is y squared. 2y squared divided by 2y is y. Copying down the minus sign. We'll bring down the next minus sign. 4y divided by 2y is 2. So that's what I have left. Now this one has a middle term that is also negative, but it has a final term that is also negative. So when I go to do my big X here, I am looking just at this, not this and this, but just at what's left over. And I'm looking for two numbers that multiply to equal -2. Remember, there's an unwritten 1 right here in front of the y squared. 1 times the last term is -2. That add to equal, remember there's an unwritten 1 here as well, add to equal -1. And so when I list my factors of -2 here, I could have -2 times 1, or I could have +2 times -1. There aren't any other choices. Only one of those, when you add them, will give me a -1, and that is this first one here. That's -2 plus 1 equals -1. Just to show you, on the other one, I have +2 plus -1 is actually a +1. That's not what I'm looking for. I'm looking for two numbers that multiply to equal -2 and add to equal -1. So it's the -2 and the 1. So my final factorization, completely factored form of this would be a bring down the 2y. Don't forget to bring that down. And then this quadratic trinomial becomes y minus 2, y plus 1. I'm just using the values here and here and pairing them with the y, and I've got it. So final answer, complete factorization, is right here. Okay, here's factoring if c is negative. So c is negative, that's the last term on here. B can be positive or negative. And once again, use the big X. We're looking for factors of, remember there's an unwritten 1 here, factors of -15 that add to equal 2. So if I list all my factors of -15, now note, we want to think about this a little bit. If they've got to multiply to equal a -15, and they have to add to equal 2, the two factors cannot be the same sign this time. Last time, when b was negative, we were looking for a couple that were the same sign, at least when b was negative and c was positive. And then when c was negative and b was negative, we were looking for different signs. That's the same case here. We're looking for two different signs. So when I list my factors, I could have -15 and 1. Those multiply to equal -15. And but they add to equal -14. Another option would be +15 and -1. Now once again, I'm just listing all the factors of -15 where one is positive and one is negative, so that they will multiply to equal -15. But I'm looking for the two that also add to equal +2. So neither of those will work. One of these equals, if you add it up, gives -14, and then this one gives my +14 if I add them up. We've also got -3 and 5, or +3 and -5, and those are all the possible factors of -15. 15. Now one of these does add up to equal positive 2. That's the negative 3 and the 5. Place those here and here. So I have x minus 3, x plus 5. That's it. So that's the factorization of x squared plus 2x minus 15, where c is negative. So I'm looking for two numbers that are different in sign. All right, next one down here, we've got x squared plus 9x minus 36. And so looking for two values that multiply to equal negative 36, add to equal 9. We'll do this one together. Negative 36 has a lot of possibilities. We could have negative 1 and positive 36, positive 1, negative 36. Then I move up to 2. Negative 2 and positive 18. And I've got positive 2, negative 18. And I realize some of you are able to just look at it and see that's great. But I want to show you a method for making sure we're considering all the different possibilities. We're not just trying to just kind of guess and check our way there. As you get better at this, you can skip writing all these down. But negative 3 and 12, and then positive 3, negative 12. Some of you may notice that we've just listed in this last pair one of the ones that work. But I want to keep going here. I want to list all the possibilities of negative 36. So I move up to 4. 4 goes into 36. And then 5 does not. 6 does. And then if I were to keep going on to 7, and then no, 8, no, and then 9, and then all I'm doing is working my way back up to here. And so I can stop there at negative 6 and 6 right there in the middle, look through the whole list, and I'm trying to find the two that when added together give me 9. And it's the negative 3 and the 12. And so my factorization here would be x minus 3, x plus 12, and we're done. All right, this one we're going to pull out the GCF first, so 3c out first. By division, we get c minus 4c minus 21. And then this guy right here can be factored further. So using our big X, we get c minus 7, c plus 3. And so you'll have to go through that process. Here's the solution. Maybe try it on your own. By applying factoring, it says a square has an area represented by x squared plus 2x minus 35. So it'd be like saying, okay, here inside the square we've got this x squared minus 2x minus 35. If you think of it as like the tables, it's as if I'm giving you all the 4 pieces that go in that square in this case. And so we have, let's move this over, x squared minus 2x minus 35. And what we're trying to do is through factorization, find the dimensions of this thing here and here. The things that you would multiply to figure out the area of the square. It'd be like saying, okay, and actually this one is a rectangle, not a square. But if I had something like this, a rectangle, I tell you the area is 12, you could tell me by factorization what the possible dimensions of it are. It could be 4 by 3, it could also be 6 by 2, or it could be even 1 by 12. And so that's what we're finding is the dimensions of the rectangle given the area of it. So that's where we're headed. So we're go back to this picture here. Given that the inside of this rectangle here, let's make it a little cleaner. The inside of this rectangle is x squared minus 2x minus 35, and we're going to find the dimensions here. And say here. All right, so we're going to find that by factoring. We're looking for factors of, there's an unwritten 1 here. 1 times negative 35 is negative 35. That add to equal the middle term negative 2. So we start listing all of our factors of negative 35. There are negative 35 and 1, 35 and negative 1. Go up to 2. 2 doesn't go into it. 3, no. 4, no. 5 does. So we've got negative 5 and 7 and 5 and negative 7. 6, no, and then 7, we're back to where we started. So we've listed all the factors of negative 35, the ones that add to equal negative 2 are the bottom one, the 5 and the negative 7. And so what we're saying is that this possible dimensions would be x plus 5 and x minus 7. Or the factors x plus 5, x minus 7 are the dimensions of that rectangle. Same thing down here. We have x squared minus x minus 72. So we're trying to find factors of negative 72 that add to equal negative 1. Remember, unwritten ones there and there. And we go through that process again. Negative 72 here, we'd have negative 1 and 72, positive 1, negative 72, negative 2 and 36, 2 and negative 36, negative 3 and 24, positive 3 and negative 24. As we see here, there are a lot of possibilities here. Somebody might have started in the middle first. It would have worked out a little better. But negative 4 and 4 goes into it, 20, 18, 19, 18 times. And positive 4, negative 18, 5, no, 6, negative 6 and 12, positive 6, negative 12, and then 7, no, 8, yes, negative 8 and 9, positive 8, negative 9. And it's not till the last one that it worked here. Like I said, many of us can just look at it and see that. I just want to show you all the factor pairs here. You got to list all of them out if you're not seeing it right off the bat. So got x plus 8 and x minus 9 are possible dimensions of that rectangle. So, all right, one more example, factoring with two variables. So sometimes we do have more than one variable in here. As long as this middle term represents both variables, we can use the same method on it. We're still looking for factors at negative 55 that add to equal 6. So negative 55, we are going to factor that. It's negative 1 and positive 55, positive 1 and negative 55. Just 2 go into it, no. 3, no. 4, no. 5, it's negative 5 and 11 and positive 5 and negative 11. So we've listed all the factors. The one that adds up to 6 would be that one. So the only difference on this is that you have an x here, and instead of just minus 5 and positive 11, we have minus 5y and positive 11y. And the reason for that is that if I'm going to distribute or multiply this out, I better get what I started with. X times x is x squared. X times 11y gives me a positive 11xy. Negative 5y times x is negative 5xy. And then negative 5y times 11 is negative 55y squared. And so you can see I get the y squared term, get the x squared term. These two in the middle add up to 6xy, which is the middle term. So you just have to tack on a y there to take care of that. Go ahead and try now you try one. If you want to pause the video, now would be the time. I'll put the answer up here in a moment. All right, so there it is. That's factoring what we call the simple quadratics.